let's look at 6.6 monitoring progress questions. So I'm getting these from the textbook. If you want to follow along with me, I'm on page 332. And these first monitoring progress questions go along with example 1. We're going to decide whether the sequence is arithmetic, geometric, or neither. We're going to look at monitoring progress 1, 2, and 3. So I wrote them down here on my piece of paper. Let's take a look at example 1, or monitoring progress 1. So I want to notice what the pattern is that's happening. How do I get from 5 to 1 to -3 to -2? Right away I notice that I am subtracting by 4. 5 minus 4 is 1. 1 minus 4 is -3. -3 minus 4 is -7. So since I'm subtracting, or in other words, adding a -4, when I add by a constant amount, that's called an arithmetic sequence. Arithmetic. And this is because the values add by a common difference is what it's called. The number that you're adding by is called the common difference. Let's look at number 2. So in number 2, I'm getting from 1024 to 128 to 16 to 2. Well, I'm definitely not subtracting with these ones. So let's see if we can multiply by a common factor. Let's start with the smaller numbers here. If I look at the ratio to get from 2 to 16, the ratio would be 2 over 16, which reduces to 1 over 8. That is what we are multiplying by. We are multiplying by 1 over 8 and multiplying by 1 over 8. So because I'm multiplying by the same amount each time, that's called a geometric sequence. Geometric. And this is because the values multiply by a common ratio, it's called. When you multiply, it's a common ratio. When you add, it's called a common difference. Okay, let's take a look at number 3. We have 2, 6, 10, 16. Well, first let's see if we're adding. This would be plus 4. This would be plus 4. But then this would be plus 6. So that doesn't work. It's not arithmetic. Let's try geometric. This would be times 3. But 6 times 3 would be 18, so that doesn't work here. It's not geometric, so that means that it must be neither. And it's neither because the values do not have a common difference or ratio. We're not adding and we're not multiplying, so neither. Okay, let's take a look at some more examples. We're going to look at example 2's monitoring progress. So if you want to go back and remember, this is example 2. We're going to find the next 3 terms in the sequence. I'm going to go down here to monitoring progress number 4. So in number 4, it says in the directions, I'm going to write the next 3 terms of the geometric sequence. And then it says we're going to graph. I'm not going to graph it, but just because we don't need to plot the points, but I'm going to find the next 3 terms. So let's take a look at number 4. To get from 1 to 3, we multiply by 3, to 9, to 27. This is all times 3 each time. So that's my common ratio is times 3. Let's find the next 3 terms. So I'm going to do 27 times 3, and if you want, you can grab your calculator. And let's plug that in. 27 times 3, that would be 81. That would be the next number. Now I need to multiply this term by 3. Let's do 81 times 3. That would be 243. That would be the next number. And again, times 3 would be 729. So those are the next 3 numbers in our pattern, are 81, 243, and 729. Okay, let's take a look at example 6. So in example 6, I'm going from 80 to -40 to 20 to -10. So I do see the numbers are getting smaller, they're going down, so I have to multiply by a fraction, and I see that they're changing signs, so I know it's going to be negative. So to get from 80 to negative 40 to 20 to negative 10, I'm multiplying by negative 1/2. Let's keep the pattern going and let's continue to multiply by negative 1/2. So negative 10 times negative 1/2, that's going to be positive 5. Let's keep going. We're going to multiply this by negative 1/2. And you can keep it as a fraction, just multiply the numerators. Remember the 5 is really over 1. So this would give us negative 5 over 2. Let's keep going. We're going to multiply by negative 1/2. Again, multiply the numerators and the denominators. And negative gives me positive 5 over 4. And those are our next three numbers in the pattern. Would be 5, negative 5 over 2, positive 5 over 4. Okay, let's keep going. We're going to take a look at monitoring progress 8, which follows along with example 4. So if you want to go back and remind yourself about example 4, but this is when we're going to write an equation for our geometric sequence using this formula here. And then we're going to find a specific number in the sequence. So here it says write an equation for the nth term of the geometric sequence and then find a sub 7. So here's number 8. I have 1, negative 5, 25, negative 125. The first thing that I want to do is I want to identify what's my a sub 1. The a sub 1 in the pattern is the very first number in the sequence, so my a sub 1 is 1. The next thing I want to identify is the r, which is what am I multiplying by? How do I get from one number to the next number? And in this one, I am multiplying by negative 5. I'm going to take these numbers and we're going to plug it into the formula. Let's write the formula down. It's a sub n equals a sub 1 times r to the n minus 1 power. I find that it looks nice when I put the r in parentheses like this. You don't have to, but it does most of the time work out that it looks nice like that. Okay, let's plug in our numbers. We're going to have a sub n equals, my a sub 1 is 1. My r is negative 5 to the power of n minus 1. Now I could leave my answer like this, but this 1 in front of here, I don't really need it because 1 times anything is just itself. So I can simplify and just get rid of this 1 here. So I can write my equation as a sub n equals negative 5 to the power of n minus 1. That would be our equation for our nth term. Our next step is now we're going to find a sub 7. So to find a sub 7, I basically want to plug in 7 in for n. I'm going to plug it in on the left side to get a sub 7 equals negative 5. Let's plug it in up here too to the 7 minus 1 power. I'm going to just put this right into my calculator here. A sub 7 just represents the 7th term. And let's put this into our calculator, negative 5 to the power of, you can put in 7 minus 1, or you can just type in 6. And there's my answer, 15,625. And that represents the 7th term in our pattern. Let's go on to number 10. So here are our values in number 10, 432, 72, 12, and then 2. First, let's find our a sub 1. The a sub 1 is the first number in our sequence here, and that's 432. Next, let's find our r value. What am I multiplying? How do I get from this term to this term to this term to this term? Since they're getting smaller, it has to be a fraction, and maybe focus on these last two numbers. The ratio of these last two numbers is the second one over the first one. So it would be 2 over 12, which reduces to 1 over 6. So that's the ratio that I want to use here is 1 over 6. Okay, let's take the numbers and let's plug it into our formula. So again, we're using this formula, a sub n equals, a sub 1 is 432, times our r, which is 1 over 6, to the power of n minus 1. Now this is simplified. I cannot simplify this answer any further because I don't know what n is. I cannot simplify. If I were to multiply this, then I would be breaking the rules of the order of operation. So I don't want to do that. That's my answer. Let's plug in and find a sub 7. So we're gonna have 432 times 1/6 to the 7 minus 1 power. Let's plug this right into our calculator and let's find out what this equals. 432 times 1/6 to the power of, again, I'm just gonna put 6. And if I want to, I can leave my answer like this. I can say it's 0.009 and I can round it to the thousandths place like that. Or I can use my calculator and change this back to a fraction. So just a quick reminder, you hit the math button, which is here underneath the green alpha key, math. And then the first option up here, it says fraction. So hit enter and then enter again. And then it gives us the answer as a fraction would be 1/108. And that would be the answer that we're looking for here. Okay, we're gonna look at one more monitoring progress question, and this is monitoring progress number 12. And this goes along with example 5. It says, after how many clicks will the zoom out button in side length of the map be 2,560 miles? So I'm just gonna go back up here and I'm gonna remind myself of what was going on in the example up at the top. And I'm gonna write down this as my table. So I have my n value and then my a sub n value, which is very similar to x and y. So my first value was 5. My second value was 10. My third value was 20. So I could just keep on going with this pattern until I get to this number here. And that would be an easy way to go about getting this answer. So let's keep the pattern going. I know that I am multiplying by 2 each time. So let's keep going. The fourth term is 40. The fifth term is 80. The sixth term is 160. We're gonna keep going here. The seventh term is 320. And if you want, you can start using your calculator here. So 160 times 2 was 320. The eighth term, we're gonna do times 2, is 640. The ninth term times 2 is 1280. The 10th term times 2 is 2560. And there I found it. I found that after 10 clicks, it will be 2,560. So my answer here is 10 clicks. Now, if you didn't want to do it this way, you could also use your graphing calculator to get to your answer. So I just want to show you. If we're going to use the geometric sequence equation, a sub n equals a sub 1 times r to the n minus 1 power. Let's plug in our numbers. Our a sub 1 would be 5. That's the first number in the pattern. Our r would be 2 because that's what we're multiplying by. So our equation here would be a sub n equals 5 times 2 to the power of n minus 1. Let's put this into our calculator. We're going to go to y equals. We're going to plug this right in here. We get 5 times 2 to the power of, and I'm just going to use x minus 1. I need to use parentheses around mine because I have an older calculator. But if you have a newer calculator, this should be raised up to your exponent. But if you have a newer calculator, you need to put parentheses, older calculator, you need to put parentheses around your exponent. So now let's go to table, second table. And let's look at these values in the table. And you should notice that they follow along exactly with this table here that we have created. 4 is 40, 5 is 80, 6 is 160. And we can keep on going until we see that number that we were looking for, 2560, was here at 10. So yeah, you can write this out and do it by yourself without using your calculator, or a nice faster way to do it would be to use your calculator and just use the table function. See how many clicks it takes to get to that 2,560.